let's try and understand what Azure Kubernetes service is. Now, I'm not going to get into the details of this service right away, but just to give you an introduction, Azure Kubernetes service is a fully managed container management service. It is provided by Microsoft Azure, obviously, which is a very popular cloud service provider. And recent stats also state that it is one of the leading public cloud service providers in the market. So when you talk about Azure Kubernetes, it is basically managed by Microsoft Azure. What it does is it offers serverless continuous integration and deployment experience. Now, what does that mean? What we can do with it? We'll discuss all those things as we get into the details of Azure Kubernetes service. For now, we need to understand quite a few other concepts before we get to that point. But to summarize few of its benefits, what Azure Kubernetes service does is, what it offers is end-to-end deployment, scalability, and availability. Now, how do these things work? We'll discuss that. But before that, let's try and understand what evolution of software development and deployment is and how it has evolved with time, right? So we all know how applications were built and how they've progressed with time, right? So if you talk about the popular ways in which software development and deployment has evolved, we all think of waterfall model, agile model, and DevOps, which is the current way in which we basically go ahead and deploy applications, right? Or basically not only develop, but also maintain, monitor, and deploy applications, right? So let's try and understand all of these one by one. Let's see how they evolve with time. So when you talk about waterfall model, agile model, or DevOps, they all have these three things, which basically sets them apart, right? The application architecture, be it their deployment or packaging, and finally, the application infrastructure that we can think of. Now, when you talk about the application architecture, the first one, that is your waterfall model, is known for its monolithic architectures, right? Something that we came away from. If you talk about current generation, we are more into the microservices model that is handled by a DevOps, right? So when you talk about waterfall, we had monolithic applications. That means everything was inside a single application. Your servers, right? Your applications, be it your management tools and stuff like that, everything was inside a single application. And these kind of architectures were called as monolithic architectures. Now, with time, we had agile model where we had multi-tier applications where some of your applications or some of the functionalities of your applications were handed over to some other domain or to some other tier, right? And hence we had multiple tiers. Say, for example, you would have your application tier in one place and you'd have your basically a database tier in other place, right? Something like that. And when you talk about DevOps, they took this functionality to a further classified, I would say, architecture where we had microservices or granular parts of your application that could function independently. Now, why do we need these kind of changes, right? Why did we not opt for monolithic applications? Now, when you talk about monolithic applications, these were bulky and these were very rigid, not easy to basically go ahead and modify. If you had to change the entire thing. When you talk about Agile, it gave you more flexibility. How? We had multi-tiers, right? So if one of the tiers is not functioning, right? So we could actually go ahead and work on that tier and it would not affect the remaining functionality. But when you talk about DevOps or when you talk about microservices in particular, it basically breaks down your application into granular chunks where each of these applications performs as a whole, but you can think of them as an individual part, which you can basically go ahead and function or operate on individually, and also ensure that you can basically make changes to these individual parts individually without affecting the functioning of the entire application. Now, when we talk about deployment and packaging, we have different ways in which these applications are hosted, right? Or in which these different ways of software development and deployment work, right? So when you talk about deployment packaging, your waterfall model supported or supports your physical servers, right? You have a physical server. Similarly, when you talk about your DevOps, or rather we have Agile first. So when you talk about Agile, you had your virtual servers. Now, if you talk about cloud computing, yes, to some extent, it supports virtualization, but back in those days, virtual servers were a little different. So if you talk about Agile model, it basically lies on a deployment model which is based on virtual servers. When you talk about microservices, on the other hand, they are more based on containers kind of an deployment is what I would say. Similarly, if you go ahead and discuss their application infrastructure, now for your waterfall models, we had data centers that basically had all these applications being hosted, right? Your monolithic applications. Similarly, when you talk about Agile, we mostly move to the hosted platforms, right? And when you talk about current microservices or your container infrastructure, we talk about cloud hosting. And that is why we've come up with this session where we'd be understanding how containers work on top of cloud. That is your Kubernetes orchestration tool. In this case, would be working on our Microsoft Azure cloud platform. So I believe the evolution of development and deployment is clear to you all. Let us now go ahead and understand or discuss some of the other bits that are there on our plate. Now, before we actually go ahead and understand how Kubernetes works, right? And why are we talking about containers and stuff? We need to understand how containers are different from virtual machines, because virtual machines are something that people have been using and many of them have migrated to containers. Why? Because both of them, they have their benefits and reasons for these benefits. So let us try and understand how a container is different from a virtual machine. More than a comparison, it is just understanding how they're different from each other. Now, this image should give you an understanding as to how these two things are different. The one on the left hand side, you have your container, and on the right hand side, you have your virtual machine. Now, when you talk about virtual machine, what a virtual machine does is, on top of your server, it lets you host your guest operating systems. To give you an example, when you talk about a service, right, or if you talk about a cloud platform like Microsoft Azure, where you have Azure virtual machines, which again lets you spawn instances or virtual machines. Now, these virtual machines or instances can have different guest OSs. Say, for example, if you launch a virtual machine that basically has a guest OS of Linux, and there's another virtual machine that has a guest OS of your Windows, right? So we are talking about two different virtual machines or entities which function on the same server, but they have different operating systems. That means if I want an application to run in Windows, I can do that using my VM, that is Windows in nature. And similarly, if I want something to run on top of Linux, I can use the virtual machine that is Linux in nature, right? So that is what virtual machines offer you. Okay. But there's a catch here. When you talk about a virtual machine, you're talking about a server, right? On top of that server, you'd be having your host operating system on which you'd be running a hypervisor. Now, this is more of a middleware, okay? Or a service that supports all the applications that are there on top of it, including the operating system, the guest operating system that we are talking about. Now, here, the problem is, as you can see, the virtual machines that you see on the left-hand side, right? They'll have separate guest OSs, they'll have their bins, and then on top of that, they'll be having the applications that are running. Now, what is the disadvantage here? Here, what happens is, each time you have a virtual machine that is operating, we need to ensure that there's a guest OS there. So there's a dependency on this. And what this does is, it makes it difficult for you to basically break this virtual machine from the existing infrastructure or architecture and make it run somewhere else, right? Because this is a complicated process. But when you talk about your containers, this is where the difference lies. Say, for example, I'll be having a Docker engine in this case, right? It can be anything. I mean, when you talk about Docker engine, it is a type of tool that provides you containers, okay? So supports container spawning for you in simple words. There are other container tools as well. We are not here to discuss Docker, but Docker is one of the most popular container tools. That is why you see Docker here. So think of it as your container image, what you see there in the left-hand side. So you can see that there's a server host, you have your hypervisor, you have your guest OS. So guest OS here is common, right? So when you have a guest OS here, what that means is all the containers that would be running on top of it would be running on the same guest OS. So you do not have a dependency where basically you have to ensure that all the guest OS requirements are also there in your container. So your container is more independent of the operating system, right? The only concern here though is, in case of containers, you have to ensure that if you have one hypervisor or one Docker engine that is running for you, right? In that Docker engine where there's a single guest OS, in that case, you'll be running all your containers that are supported by that guest OS, right? Now, if my guest OS is Windows, I cannot expect myself to run Linux containers there. I'm just giving you an example, okay? So there's a drawback there. But the benefit here is, right, since your applications, your bins, and your library files are independent, you can package them in a container and move them across easily. So you can run it on other Docker engines as well to support your claim. What that does is, since you have this freedom here where you're not dependent on your guest OS, right, or you do not have a guest OS inside your container, you get certain benefits. It makes your containers faster, okay, makes them reliable, and at the same time makes them efficient. So that is what basically containers are, and that is how they're different from virtual machines. So I hope by now the point here is clear to you all, as in how do these things function. Okay, let us now go ahead and understand the other bits. Let us now go ahead and understand Azure Kubernetes service. Now, to give you a brief about Azure Kubernetes service, as I've already mentioned, it is a Kubernetes service that is hosted on the Azure cloud platform. Okay, so let me just go back to the slide one and explain that again so that we can go ahead and understand how working of Azure Kubernetes happens. So we've already seen this slide, right? What is Azure Kubernetes service, but now it would make a lot more sense for you. Okay, so what can happen, or what Azure Kubernetes service offers to you. Now, if you talk about Azure to start with, it is a popular cloud service provider. What that means is, with Azure Kubernetes or with Microsoft Azure, you can basically have various services that help you in software development, planning, management, right? Be it your administrative practices, development practices, or architectural practices related to a software. All these things can be hosted on a public server in this case, which again can be your Microsoft Azure cloud. Now, what it does is it basically gives you all the services that are needed to carry out all the actions that I just mentioned, where you can rent these resources or follow a pay-as-you-go model and use these services to benefit your requirement. Okay. Now, when you talk about a platform like Microsoft Azure, which again is a cloud platform, as I've just mentioned, the possibility of dealing with applications are plenty, or the possibilities rather are plenty. So you can do so many things. So what that does is that gives developers or application owners options to work with these applications in numerous ways. Okay, it simplifies their complications, right? Since if you're talking about a platform like Microsoft Azure, it helps you basically orchestrate quite a lot of activities, be it managing your servers, infrastructure, right? Be it basically load balancing, be it auto scaling. All these things can be controlled by using the cloud platform. So what that does is that gives developers this added benefit, okay, or the application owners this added benefit. And that is why what these cloud platforms are doing these days is they are encroaching or basically covering different domains, be it your big data, DevOps, analytics, right? All these things are or can be implemented using these cloud platforms, because when you talk about these cloud platforms, they're already owning various markets of software development and application hosting. Okay, so that is why having something like Kubernetes work on top of Azure is a benefit. Why? Because some of the complications that you'd find difficult to implement using Kubernetes can be controlled by using Microsoft Azure. And that is why you have these added benefits, be it your end-to-end deployment, be it your availability or scalability. If you talk about some of the benefits that it actually offers, what it does is you pay only for the nodes that you use. That means last time I checked, Microsoft Azure did not charge you for your master node. You only get charged for your worker nodes that you use. Okay. Your cluster upgrades are easier, so you do not have to worry about the patching part and stuff like that. Integration with various Azure and other tools and services becomes easier. Not just that, what you can also do is you can actually go ahead and enforce various rules that are under Azure policy across multiple clusters to have uniformity if you need to, right? What you can also do is you can scale Kubernetes and other nodes using autoscaler that Microsoft Azure supports. And you can even expand your scale even greater by scheduling your containers on Azure containers. So that is what Microsoft Azure Kubernetes service provides you with. Okay. Let us now move further in this Azure Kubernetes service tutorial video, and let's try and understand some of the other important pointers, like how does the architecture of Azure Kubernetes services works. Okay, to understand the working of AKS or Azure Kubernetes service, right? You can see this diagram on the screen. It's a fairly simple diagram and it tells you what Azure Kubernetes service does. Okay. So we've already seen how Azure Kubernetes architecture works, right? I mean, we know what all components it has and stuff like that. This is a more detailed view. So what you'll have is you'll have again a Kubernetes master node or cluster is what you can call it. Okay. So in this master node, the functionality would be same. It would be controlling how the deployment and how the management of your containers work. So basically, Azure will manage your master node. It will basically help you control quite a few activities that are there. As a customer, you'd be managing the applications only. There too, you would have support from Microsoft Azure. How we would understand that? Now, if you talk about the control plane, what you have here is you have your API server. Now, when you talk about your API server, what it does is it basically tells you how the underlying Kubernetes APIs are exposed. Okay. What this component basically does is it provides the interaction for your management tools, be it your Kubectl or the Kubernetes dashboard. Similarly, you have your etcd. Now, etcd basically what it does is it maintains the state of your Kubernetes. When I say the state of Kubernetes, I'm talking about the Kubernetes cluster, and basically it helps you control all the configuration that is there. This thing is highly available and it is key value based in nature. Okay. What you also have here is basically you have a scheduler. What your scheduler does is it lets you create and scale your applications to basically determine which nodes can run on what workload and stuff like that. Okay. And finally, you have your controller manager. Now, this is an important bit again. What it does is it controls or oversees a number of smaller controllers, whether they're performing their actions or not. And what it also helps you in doing is replicating the pods that you have and handling your nodal operations as well. So this is what your control plane does, and it is basically managed by your Azure. Now, what is the benefit of having Azure manage it, right? Since Azure is managing it, you do not have to worry about the configuration part, setting up part, right? Your cluster node is basically set up by Microsoft Azure, and that is what it simplifies. Then the other bit is your customer managed bit, be it your kubelet, right? Kube proxy, your container, and container runtime. To understand this better, I think this diagram should draw a clearer or a better picture for you. Okay. So basically, when you talk about your customer part, now there are quite a few things that you need to know. I've mentioned kubelet, which basically lets you run your pods, right? Your pods are run by your kubelet. That is what your kubelet does. Okay. There are other things as well that you need to know here. You have your Azure Virtual Network Interface. Now, it is something that takes care of all the interface requirements that you might otherwise have. Okay. And similarly, you have your kube proxy, right? Kube proxy again works together with your virtual network interface, right? Or basically your Azure virtual network and tells you what needs to be done. Okay. Now, all these things, they reside on a virtual machine again. So we've discussed all the differences and benefits of it. So what Azure does is it basically launches a virtual machine for you on top of which your containers would reside. Okay. So when you talk about these containers again, these are nothing but your applications that are running for you. Okay. And these are the services that would help you actually implement or control all these applications that are there. You can actually go ahead and scale up your virtual machines to meet the requirements of your application in different ways. So this is how the working of AKS is. I mean, this is how the master node works, and this is how your basically customer node or your worker nodes work when you talk about AKS. We'll see these as we get into the demo part. But before that, let's go ahead and understand a use case or see a use case as to how vehicle safety with AKS is supported. Now, when we say vehicle safety, we are talking about a use case that was set forth by Bosch. Okay. Bosch, as we all know, is a very popular company which has numerous thousands of employees working across the globe for meeting different technological needs of the world. Okay. In this particular use case, what they thought of was the amount of accidents that happen due to wrong way driving. Okay. And what they thought was, could we find a solution that could basically help us overcome this bit of problem? Okay. So what were the problems that they were facing, right? When you talk about wrong way driving problems, right? what are the issues that we face? Okay, because of wrong way driving, there could be a lot of accidents, unplanned casualties, and stuff like that. But if I am to avoid a wrong way driving using technology, it's a very tedious task. The reason for that is what I can try and do here is I can basically set up an application that notifies me of wrong way driving, right? But then for that to happen, I have to have a lot of data that is in real time. And when I'm driving, my only way of fetching data is by using cell phones and GPS, right? But then again, there are problems with these things. When you talk about cell phones, they basically function very well in a radius of 5 meters distance when you talk about their operational radius rather, or their limitations when you talk about range on exchanging this data. Okay. So you can transfer data to a larger audiences. We see that through WhatsApp and stuff. But if you talk about GPS kind of data, we are talking about multiple points or multiple data that we are dealing with. And to deal with them parallelly can be a difficult task. So because of that, Bosch felt was that this was an impossible task to deal with. Why? In order to get the last piece of information out of the noisy sensor data can be a problem. And in order to develop a highly scalable and ultra flexible service to process this data in real time can also be a tedious task. What they also figured out was to solve this problem, they needed this data in real time and in very short duration. If we could do that, we could actually go ahead and save accidents and we could save these wrong way driving incidents. And that is why they decided to work with Microsoft Azure, which was their already supporting partner. What they also did was they ensured that they did go ahead and accommodate Azure Kubernetes service in their infrastructure. What this did was it ensured that Bosch would get repeatable, manageable clusters of containers. And since they work in such shorter durations, do not have latencies in minutes, but rather in seconds, they offered a simple form of services for them to work with. And what that ensured was they had the average time to calculate whether a driver is going the wrong way or not in milliseconds. So around 60 milliseconds they could figure out. That is around a second where they could figure out whether a driver was in the wrong way or not. And that is what basically your Azure Kubernetes service enabled them to do. Their major problem, that is they had the time constraint. That is something it helped them solve. And because of that, they could come up with this wrong way driving problem solution where they basically use Microsoft Azure to host their data and basically Azure Kubernetes service to basically help them in simple provisioning, scaling of applications, and ensuring that the real-time data is made available to the drivers within a span of 60 milliseconds, which again is a big achievement. So that is what AKS or Azure Kubernetes service had to offer. If you go to Microsoft Azure's website, there's so many good use cases that talk about AKS. So you might want to go ahead and take a look at that as well. As far as the session goes, we'd go ahead and take a look at the demo and understand how we can actually go ahead and set up an Azure Kubernetes cluster and a lot more. Okay, so guys, let's go ahead and get into the demo part now. This is how the Azure portal looks like. Okay, I've signed into the Azure portal. Now for people who are new to Microsoft Azure, what Microsoft Azure does is it gives you an Azure portal where you can implement all the cloud related activities that concern Microsoft Azure. Okay, so if you want to practice from scratch, it also offers a free tier account where you have a number of services available free of cost. Okay, or rather in case of Azure it works differently. For AWS you have those free services. With Azure you have this $200 of credit that it gives you, so you can spend those $200 on creating resources for 11 months duration. Post that, those will expire. So if you do not have an account, you can just go ahead and create a free tier account, fill in the details, right? And you should have this free Azure portal for your usage. Okay, in my case this is a paid account, this is the company's account, so it's called as pay as you go. In my case, in your case it would be a free tier account, but the functionality would be similar for you as well. The only thing is with the paid account you have more services available to you, and even the larger instances is something that you can actually go ahead and spawn and use because you're paying for those, right? Under free tier you don't have to worry about paying for them, right? So there are certain restrictions and limits there. So do go ahead and register to Microsoft Azure's portal. Okay. Now coming back to the demo part, what we are going to do now is we are going to create a Kubernetes cluster. And on top of that, we are going to deploy an application and the application would be a basic pre-built app by Microsoft Azure. We are not going to create a new app. I'll be sharing the code for the application, so do not worry about that. So we are just going to go ahead and use that pre-built code, and we are going to deploy that code on top of Kubernetes cluster that we have. Okay. So the main thing to note here is we have to see how easily the cluster is created. We are not concerned about the orchestration process at all here. Everything is taken care by your Microsoft Azure, and that is what we are going to look into. So let's not waste any time. Just quickly go ahead and get an instance in place, rather a cluster in place. Okay. So to do that, we are going to click on this icon and say create a resource. Okay. Here you can see all the service domains that are there for offering. So I'm going to click on the containers one and click on Kubernetes service. Once you do that, you see you'll be brought to this page and you'll get all the details, right? AKS manages your hosted Kubernetes environment, making it quick and easy for you to manage containerized applications. The main point is without having to container orchestrate or have any expertise in that. Okay. It eliminates the burden of ongoing operations and maintaining, provisioning, upgrading, scaling your resources rather, which happens on demand here. So you don't have to worry about those things. So let's just go ahead and create a resource group. So for people who do not know what resource groups are, resource group is nothing but you can think of it as a small container or a folder where you put forth all the necessary things that are important for your resource to work. Now, in this case, our resource is Kubernetes. So quite a few other nitty-gritties related to it would be in the resource group. Okay. So let's just go ahead and create one. So I'm going to click on create new. Let's just say we have RG for demo. I'm going to give a simple name so that I can remember that. Okay. So I'm going to say okay. I'm going to create a cluster. I'm going to call it cube cluster. Okay. This is enough. So cube, let's call it cube cluster. Okay. And this is in place. Where do I want it? If you're using a pay-as-you-go model, there won't be any restrictions here. If you're using free tier, there might be some. Okay. So just select any region that you want to do. I'm going to randomly select a region now. What region it should be? My region would be, okay, let's pick this one. And it would ask me how many nodes do you want to create? Let's create one. Since it's a very simple demo, we do not need more nodes. Okay. We've discussed what nodes are, right? So that is what we are doing. We are creating a node here where our application would run basically. So I'm going to say review, or let's just go ahead and see if we have all the settings. Node pools. Authentication, you have two options, whether you want your server or rather your cloud platform to manage your identity pools and basically create resources accordingly. You can do that, or you can select a service principal, which is an older way to do it, where you use an Azure Active Directory to do that. So there's no rule here. You can go for this one as well. I'm just going to do this just because I've thought of showing it to you. I selected that. It does not hold a lot of impact on our demo. Okay. Just gonna say create and review. Okay. So for creating this thing now, it will review all the requirements. If the requirements are in place, what it will do is it will just go ahead and create your cluster and put everything in place. Okay. So it says, do you want to create it now? I'll say yes, create. Okay. Let's just refresh and see whether our application is done. It's still deploying. Let's wait for this deployment to get in place. And once it's done, we'll just go ahead and get these things in place. After this, the process is very simple. Okay. We are going to just go ahead and put in certain set of commands and our job would be done. So you don't have to wait for too long post that. Okay. Let's just refresh it again and see whether it's in place. Normally it takes a couple of minutes, so could take longer, right? But it's a very easy deployment process. So let me give you an idea as in what happens when you say that the deployment is happening. So first your Kubernetes will actually go ahead and launch a Linux instance to start. Okay. So once the Linux instance is in place, that is when we'll actually go ahead and put forth all our resources on top of it. In that Linux instance, we'll set up a cluster, right? All the nitty-gritties that we need. And on top of that cluster, our application would start working. Here in this case, it would probably set up a cache. Could be a Redis as well. We'll have to go ahead and look into it, whether it's that one. Okay. And then accordingly, we can go ahead and implement everything on top of that. But we don't have to get into the complications of things. It's a fairly simple process for us. Okay. Okay. Let's just go ahead and refresh it once more. Okay, it's done. Your deployment has been complete is what it says. That means we are good to go ahead and use our resource. You can do other things as well on top of it. It is suggesting what all you can do. Okay. So we are going to do one of these things. Do not worry. So just go to the resource in our case. Okay. And in this resource, you can see there's all the information that you need. Okay. You'll get to know where it is hosted and stuff like that, what kind of instance it is, where it is located, everything. One node pool is what you have, right? So you have all the information to actually go ahead and connect to it. So in your case, I'm hopeful that it would happen faster than what you see in my case, or on my screen rather. You see, Cloud Shell is up and running. So let's just go ahead now and basically get credentials, right? Here, let's get the credentials or merge our cluster, okay, so that we can start using it. So how do we do that? We use this command. We say AKS, okay. And in this case, what we are going to do is we are going to say get credentials. Okay. Now the next thing is, what do we need? Resource group details. So I'm going to say resource dash group. And I'm going to give the resource group name, which I am certain that we should see if we just scroll up. Okay. So the resource name is RG for demo that we used. Okay. RG for demo. And what we also need is we need the name of the cluster. And in that case, it is cube cluster. So you can do it vice versa as well. You don't have to go this order. You can start by giving in the details for your cluster and then the detail for your resource group. I'm just going to hit the enter button now. Merge cube cluster as a current context in this path is what it says. Okay. Now let's just go ahead and get the details for the node. In this case, we know there's only one node, but you could be working on multiple nodes, right? So in that case, you have to use this command. You say kubectl. Now it is basically a client-side interactive tool for interacting with your Kubernetes. Okay, so that is what kubectl is all about. Okay, and you say get nodes. If there are multiple nodes, it will give you multiple nodes. If there's only one node, it will give you only one node. So there you go. You can see that there's one node that we have with us. Okay. We have all the details. It's been running for 5 minutes, it says, right? Because that is when we started the node. Okay. Now the next thing is we are going to go ahead and select the YAML file where we've actually put forth the details for our application, right? So how do we do that? For that, we are going to go ahead and use this command. Okay. Nano. Okay. Space Azure. The name of the application is, or the application rather, is related to voting. So that is why I'm going to use this name, and I'm going to say .yaml. Okay. Okay. So guys, I've already pasted a piece of code here because I tried implementing this demo before. So you'll see that there's code here. Okay. So in this case, what we are going to do is we are going to remove this code just to be safe. I'm going to just paste the code again. So basically, this is where you'll have all the details. What is the API that is being used? What is the container port, right? What is the memory that you are using? What call are you making, right? All those details are here. Do not worry, I'll share the link to this piece of code in the description. If not, you can just look for Azure demos or getting started with Azure on your browser and you'll find this piece of code. It's available everywhere. You'll get this code on GitHub as well. I do not own this code, so I will not take any right in saying that this is something that I've created. It is a code that has been used and it is somebody else's work. Okay. So you may check out online the details. I'll also pass in the details in the description. Okay. So everything is removed now. I'm just going to go ahead and paste my piece of code here. Okay. I'm going to say paste, and all the same code is again here with us. Okay. Now, how do I go ahead with it? In this case, I'm going to say justify, cut, uncut. Do I want to replace? I'm just going to say exit for now. So it's Control X in my case. And I'm going to say no, we'll discard the changes. So we'll say yes. So Y. That means it will save my code. Okay. I'm going to hit enter now. So it will take me back to my cluster. Okay. The next step is, now what we are going to do is we are going to go ahead and call out this YAML file. Okay. So once we do that, this is how we are going to do it. We're going to say kubectl again, okay, and apply /f Azure. What was the name again? /vote dot YAML. I'm going to hit the enter button. And there you go. What it has done is it has created a vote back application. Its front is created, its back is created, right? So we need to see how it looks like, right? So we are gonna find out all the details, as in if we want to watch this app working, we need the details for it. So we are just gonna go ahead and use a command called as get service. Okay, so get service is in place. And in this case, again, my app name, Azure vote, but this time I want the front. Okay, so I'm gonna say front, and I'm gonna say watch and hit the enter button. I basically made a blunder here, and that blunder is we have to call this command through kubectl, right? So in this case, again, we'll have to type the remaining command again. So I'm just going to do it quickly. Okay, get service Azure vote dash front watch. And there you go. You have your external IP here. So guys, at times what you see here, your external IP, if your system is very slow, which is in my case, but I don't know how it happened. It says is only 85 seconds is what it says. So normally it takes time for you to see this external IP. Okay, but luckily we can see it. So I'm gonna just copy it here. Okay, and I'm gonna paste it here. And this way we should be able to see the application that we've created. Okay, so you can see you can vote here. One, let me vote for dogs, twice, thrice, and I can just go ahead and reset it as well. Okay, so guys, this is how you actually go ahead and create a cluster. Okay, a suggestion here would be you delete all the resources that is there. Delete this one, delete the resource group, and also the Azure Active Directory, so that you do not get charged. If you want to see what all we did here, right, and how the performance went on, Azure lets you track all the working as well, right? If you want to take a look at the insights and stuff, if you click here, you'll have all those details as well. So there you go. If I just refresh it, you should have all the details, right? How long did we use the cluster? This is where the usage started. Okay, so you'll get all these details that you want. So you can do that. So that's it. I believe this demo was clear to you people, and you got to know what things we've worked on, how we've used these things, and how basically your Kubernetes cluster works. Okay, so we've created a simple Kubernetes cluster and explored it. Ensure when you go back, you just delete. Just go to the resources and delete the resource group, the cluster, and the Active Directory if